Thank you everybody, and thank you Matt. We spent plenty of time in this lecture theatre, and I went through uni with Matt and he was mainly asleep, but I was probably up there beside him too, so this is probably the most attentive I've been. Thank you to the DAF team for inviting us as Lalamond here today. It's always good to be part of these events and hear what's happening. And today I was given the brief on how we utilise silage technology, and with that think about, you know, as Professor Nussio said, about producing a better quality forage and in that a clean feed. Now is it down or up? Down, righto. So just a bit on Lalamond and our core business. So we're a yeast and bacteria manufacturer, as well as fungi and their derivatives. And we guess, where do we touch people's daily lives? You know, we've got a wine business. We focus on utilising Bilardi yeast in piglets. I see there was some stuff here on tomatoes, and I actually asked some of our global team, well, how does Lalamond have an effect on tomatoes? And we've been looking at bacterial fungal controls to treat fungal infections in hothouses in Italy. So, you know, yeast and bacteria have a lot of different roles in the way they work in society and in agriculture, and we're pretty proud to be involved in that. And with that, you know, we focus on a number of different species. We perform a number of trials across a number of different organisations every year, and are proud to present a number of different peer-reviewed research papers in a number of countries. And 1 in 12 of our employees are dedicated to research. So you've had a pretty good high-end scale of speakers with researchers and professors, and now you've just got the silage bloke that runs around the Darling Downs, so we'll see how we'll go. But in terms of that, no matter what we do, we want to make sure that when we're producing forage, we produce a clean feed. We know with all the work the guys that do here that silage quality underpins rations, especially in a dairy situation. And you know, I guess that starts from you know, agronomically. We've got a lot of seed companies in the room, that how we get that crop planted and then how we harvest it. We want to make sure we can protect and store our silage effectively, and then we want to make sure we can present that in a ration to an animal in a way that's going to produce milk or beef. And we work a little bit in herd health in terms of rumen boluses and some microbial products there for managing dry packs and things like that. But that's just an idea of what we think about when we think about clean feed. We want to think about it as a whole approach. You know, we know now that silage has become a very, very valuable resource across a lot of animal industries, and there's people here that have been around a lot longer than me that were probably in the room when silage first started out. I won't point any names, Mr. Busby, but you know, 88% of silage now in dairy farmers are using it, and it's increasing. We're seeing beef herds starting to utilise silage as a resource, whether it be to control mating or maintain breeder herds, or looking at it as a tool to utilise in their weaning programs. And we've got a better understanding, I think, than what we did in the early 90s on how we can store feed and store it quite effectively. And we see this real, I guess, multiple storage systems used in forage. Are we looking at feed short term, so for the next season, or are we looking at it in the medium term and then also long term? And we're definitely seeing a push where people are thinking, you know, we used to have 18 months to 2 years supply of feed down, now we're going out even longer than that. And I think, you know, 2018 and 2019 embedded that all in our minds, that we need to have a bit of a longer term view on forage preservation. You know, what we see in the past isn't definitely the future. I guess, you know, our first impressions of silage, we just ran a field day, not a field day, we were a contributor to Beef Australia in May. And we had a few different types of people that would come in and see us. There were people that have never made silage, or people that have made silage and used to experience this and say that was black, you know, smelly stuff that we don't like to use. Like, how can we get away from that? And then there's the, I guess, the silage user then, who is actually using it, wants to do that better. And now I think as an industry, you know, we need to make sure our forages are like this. And that, I think, is the benchmark, and that's an accepted quality of forage. And this is what we strive to do, I guess, not only within Lalamond, but as an industry. And you know, you look down the bottom, it has been said before, and there's a lot of nutrition people here, you know, cow nutrition can only be as good as the forages we put in front of them. I can remember a late colleague of mine, you all would have probably met, Trevor Squirrell, said to me when I first started, you know, we don't clean out the trough and we do all these funny things with forages. It's like getting a Sunday roast on Sunday night and you put on your plate. Then you don't clean the plate for the rest of the week and you expect the bloke to feed that plate on the next Sunday, after having cleaned it for a week, to eat the same amount as you did the first Sunday. It won't happen. So hygienic feed, I think, is important and plays a key role then in some of our rations. You know, I think the key drivers for this use now is that we've had improved sealing systems, so there's improved storage in that space. We understand now how we can preserve that, and some of that technology, because harvesting machines have come a long way. Professor Nucio said about their pool machines, tag machines, you know, and they are still a part in different parts of the world, but probably not here in Australia much anymore. And this was a stack on the Darling Downs where we've seen some silage that's been down there for 2 years, and to open up a stack like that, I think is pretty impressive. It's no different if we went and took $100,000 and put it into your nominator bank account, and at the end of the term deposit, your bank manager said, "Oh no, look, we've had a fair bit of waste and spoilage, and we didn't have the interest on that product this year. We're not going to give you as much as you put in." We've got to make sure that we get out of those forages to what we put into them. And we've been, you know, there's been, I suppose, advancements in that around sealing systems and inoculant technology, and something that we've been quite interested in looking at within Lallemond is a bit of metagenomics. So what that's looking at is actually the study of the genetic material within the forages. So we say we're inoculating forages and we're putting certain bacteria on there, but what are they actually doing within that? So we want to be able to see the presence of desirable, undesirable microbes. And you can look at that by looking at the DNA sequencing of that bacteria and of those yeasts and moulds and different fungi. And you know, I guess that's important to know how it happens from day one, from when we start to apply them, out to day 5 and day 10 and out to day 60 in some cases. And I guess if we understand this, we know how we can produce clean feed. So don't get too hung up, I guess, on this intense slide, because it's probably not my expertise, I can assure you. But what we're mainly looking at here is forages. When we're looking at the metagenomics of that, so as I said, it's the DNA sequencing of the bacteria. So this is a control product here, and this is a product being treated with Buckneri and Hilgardii bacteria. Is the change actually in the Buckneri and the lactobacillus that are actually improving within the silage fermentation. So we see in the early days, at the start of these studies, at day 1 and 2, we see that the native, I guess, bacteria that are present on the plant to start with, and they're always there, and they're always going to initiate a fermentation. I know we go to a lot of people and they say, look, we need inoculant to produce silages, it'll happen itself, and that's true. There are natural bacteria that will kickstart a fermentation, but are they going to kickstart that fermentation as rapidly and to pull the pH down and preserve as much energy as we want throughout that process, or are they going to continue to burn out in that forage heat for a longer period of time? And we can see here that they are vital in kick-starting it, but they don't prolong it. You know, I guess Buckneri here is a bit of old technology. It's still utilised within inoculants, but we've got Hilgardii now that's sort of a new strain-specific product that works, I guess, synergistically with Buckneri to produce that fermentation. And we can see with these lenticacées that we're starting to see this kick-start the fermentation. However, over time, if we look at 4, 8, 16, out to 64 days, we're starting to see these other lactobacillus bacteria dominate the fermentation. And that's the important part. We want to see that because then we know that we're getting aerobic stability, we're getting stable silages now within days, not weeks. And we know that when we get that aerobic stability, we're actually getting that in a lot sooner than when we did with previous technology out at 30 and 60 days. So this is a way, I guess, we can highlight to prove, well, not so much to prove, but I guess to give us confidence in how these bacteria are working on the forage mass. Because I think it's, I know that when some of the contractors first started using a product we had called Lalsil, one of the jokes out in central Queensland was, well, that's good, it keeps our silage cool on our face now for a couple of days. So a bloke feeding Brahman steers out west would say he could go to a camp draft on Friday and the silage would be still cool when he got home on Sunday. And I guess now with Hilgardii technology, I guess he could have a long weekend. And that's, I guess, looking at that from a metagenomics response, but then if we look at that from a processing, and everyone's sort of touched a bit on that about how we actually process our forages correctly. And these are some very, very crude, might I add, I guess, rules of thumb. And I think there are options out to 26 millimetres now as these larger harvesters have different knife drums and have different processes to get an improved, I guess, kernel processing. But at the end of the day, we need to get a compaction. And Professor Nussio mentioned that before, and I think it'll be good, and I'll follow up later on with the trial in China to see what sort of packing densities they work on over there compared to how we work in Australia, because it'd be great to get an idea on tonnes per hour coming in. But the rule of thumb, as we said, is dry chop. If a crop's dry, we chop shorter, and if it's wetter, we chop longer. When we process these forages, as we said before, this is a bit of a picture on how crop flows through a machine. So it comes through the rollers, it comes through what they call into a smooth roller, present the forage into a package. You've got a knife drum here that runs at a constant speed. These rollers here are what actually feed the crop into the machine to adjust our chop length. So it's important that, yes, the knives are sharp, our shear bar square. Then there's the rollers up here, the grain processing rollers, as to how they're going to process that grain. Now with new machines now, they can sharpen those knives multiple times a day, and that's common practice, I think, with some of our contractors. But we're driving, I guess, the ability then to extract the starch, whether it be from a waxy or a non-waxy sorghum or a corn silage or a forage sorghum. If we don't process it, that we know that we're not seeing improvements in starch availability. And we know that I've spent a bit of time sieving through a lot of forage sorghum samples, and that just the inclusion of a grain processor can hit 40 to 45% of grain sorghum. And the processor not only affects that grain sorghum, but it affects how that forage particle is then presented to an animal. So you think of that now in a rumen and in terms of rumen digestibility and how the gut bacteria then digest that forage. And we talk about kernels and whole corn kernels in corn silages. We like to have no kernels whole in a 1 litre container. So we have a 1 litre container that we go around and we check corn processing as choppers are processing corn. And we can see that as we increase those numbers of kernels per litre, we're out to about 6 tonnes of grain per silage as cut. Now that's 6 kilos, per tonne as cut. So that's a lot of corn grain that we're starting to see. If you chop 1,000 tonnes of corn silage, you think of how many whole grains, and we've missed the opportunity of digesting that starch. That number there, you think, well, why are we having that discussion around that number? Well, people say, well, should we actually potentially say to our contractor, we want that processor in and we want it set correctly, we can afford to pay 50 cents a tonne more if we want to make sure that happens. You can afford to do it. And it is worth the discussion, and I think most of our contractors here will be forthcoming in that discussion, because it ensures that the quality of their result they give to you at the end of the day. And we definitely want to see a lot more kernels, processed like this than like that. And I think this is the gold standard. Where we probably run into some of our issues, that when we see a season like this, where we've had such a wet summer, we've had optimal, harvesting times have really been compromised. We've seen a lot of over mature crop. We haven't had the ability then to process those as effectively. We're going to have to make compromises. This is some work put together, and some people in the room would realise this, by Dr. Bruce Hamilton. So this was looking at starch digestibility over time. So if we go back a step, we looked about how we process that starch. Now this is putting that product into the pit. And I guess if you think you're a betting person, there's your probably sweet spot. That 5.5 to 6 months of time in the pit and siling is where we get the best bang for our buck on digestibility of starch. And if we overlay that then, I guess, into months and siled to extra litres per cow, in a dairy cow eating 5 kilos of corn silage from dry matter per day, there's definitely money in that milk to extract that starch. And if we don't do that to corn silage, we might as well grow a forage sorghum, because otherwise we've grown a very expensive forage sorghum and we haven't utilised the value. And in saying that, we can also optimise our forage sorghums or our grain sorghums. You know, there was talk there before from Diego about processing grain and how we get the most out of that if we didn't have the access to technology. I know that in areas now we're harvesting grain sorghums a little bit on the damper side, and guys are processing them, wetting them up to 32% moisture, inoculating them and ensiling them, and nutritionally that'll feed as well as the dry rolled wheat. So I guess that's how we can maximise the value of that grain sorghum. We want to make sure when we get our investment that we seal it, and seal it for the time that we need it to be down for. And there was a discussion previously around how we cover silage, and I think that's a term we need to not think about. We need to think about sealing your crop and sealing that correctly. We know that the use of different sealing weights and things like that play a big role, and plastics have changed over the years from when we didn't use plastics to where we're seeing 2 and 3 layers of film for 5 and 6 years worth of storage time. Utilising lime or dirt around the edges is another great tool. I know in some places you can't find bags or we can't find ties, so there's options for you. And then I guess there a UV, and that's a fair dinkum picture, it's not been photoshopped by the way. There was a cow, there was another one where we had some sheep, or one fella down south bought these protective nets because they had koalas climbing on top of the corn silage pits and digging holes and eating the kernels out the top of the silage. So, that's, I guess, protecting your investment going forward. And I guess that's our outcome, as we said, and we can know we can get that. That was a stack that had been down for 2 years, so I think that's a pretty impressive result. And as people have said in the previous discussions, we want to be trying to look at silage shrinkages. In the old days we were at 20 and 25%, but I think we really can be effective in getting them down sub 10% now. Just before I finish, Reynolds, I don't want you to stand there for too long, but silage sealing is important when we look at the films. So are we using a conventional PE film? Are we using an oxygen barrier film? And oxygen barrier films have really changed, I guess, the way we manage that top half a metre on top of our silage pits. We need to make sure that we're using research-backed oxygen barrier films, because we know that forage without air is silage and forage with air is compost, and we've all seen the result of that, and it doesn't take very long at all to start to lose 100 or 250 tonne across the top of a 20 by 50 metre bun stack when we're getting air ingression into them. Something that's probably come across our business of late, whether that be from corporate farms or from other industries, we're looking at is this buzzword around sustainability and plastic use and things like that. And we put some numbers, and these are just to think about. These are not to say that we need to go and do that, but this is just to think about that. Baled silages are a big part of the industry. And we can see there we have a reasonable plastic use per bale, and there's opportunities, I guess, to reduce that. I know Dairy Australia working on how we can improve, I guess, in terms of recycling baled plastic. Then we look at bulk silage and single layer films versus double layer films, and that's with 180 to 200 micron plastic, so thicker type of plastic films. And then we look at reusable cover systems. So when we're going on to multiple covers, we're using oxygen barrier films. And we can see that with that, we're starting to reduce the usage of plastic per dry matter tonnes. So there's some good numbers there to think about as an industry on how we go forward. And also, I guess, the pressures on ties. We're seeing that down south where we're getting a lot of pressure from the EPA and different organisations about the use of tillage as sealing weights. But that's not to say we need to change the way we seal our silages now, but that's just, I guess, a thought process that we all probably should take into account. Look, in summary, thank you very much. I think quality hygienic silage is very achievable, and it's something we should all strive to, I guess, achieve, and zero waste is an achievable target. That's visible waste. Well-made silage we know will drive rumen function. And at the end of the day, the cow is the customer, so we don't want to make sure that we let forage quality be the limiting factor. So thank you very much, and I'll hand over to the next speaker.